Okay, so we're going to do a lesson on how to deal with linear equations when they're in a form called slope-intercept form. And slope-intercept form is aptly named because the information that the form gives you is the slope and the y-intercept of the linear function. So let's get some of this written down. So slope-intercept form is y is equal to mx plus b. The m, notice the m is the coefficient of the x. So sometimes in slope-intercept form, the b and the mx will be switched around. So keep in mind that m is always the coefficient of the x, and that always refers to the slope of the line. The b is always the constant, and it's referring to the y-intercept of the line. Another kind of trick that I saw, but I kind of like, because m and b, it seems awkward that those would not be named s and like y or something like that. But I kind of like this idea. If you think of the b telling you where the line begins and the m showing you how the line moves, and that kind of helps you graph it. Now, this might be my most, like my cheesiest moment as a teacher, but I created a cheer to help you remember how to graph lines if you're given slope-intercept form. So here we go. It's really bad. So it says, if you want to graph a line beyond all compare, plot the y-intercept first, then rise and run from there. So I'm going to do it one more time for you. If you want to graph a line beyond all compare, plot the y-intercept first, then rise and run from there. The reason I made it is because a lot of times the students would try to do slope first and count from the origin. So if you're going to graph a line, a really good way to do it is identify what your y-intercept is. That's your b value. You're going to plot that y-intercept. Where do you plot it? It's on the y-axis. And then you're going to rise. That's your up and down movement. And then you're going to run. That's your left and right movement. And you're going to, the place where you start going up and over is from the y-intercept. So you rise and run from there, from the y-intercept. So if it helps you, great. If not, you can ignore it. All right, so we're going to do some examples where we're given the slope and the y-intercept of a line, and we're going to write the equation in slope-intercept form, and then we're going to graph it. So here, the slope is 2/3, the y-intercept is -4. Remember, the slope corresponds with the m, and the y-intercept corresponds with the b. So can we write the equation of our line? We can. It's y is equal to something x plus something. So here, the m is 2/3, the b is -4, and we can kind of clean that up a little bit and make it 2/3 x -4, because plus and negative is the same thing as minus. So now remember, when we graph this, we're going to plot the y-intercept first. So our y-intercept is -4. So we're going to plot an ordered pair on the y-axis where y is equal to -4. And then we're going to rise and run from there. So let's talk about rise and run. Rise is the numerator of your slope. So this is your rise. So what we're going to do is go up 2, and then the 3 is your run. Notice both of those numbers are positive. So we're going to go right 3 for the run and up 2 for the rise. So from the y-intercept, we're going to go up 2 and right 1, 2, 3, and then we can connect our dots with a line. Keep in mind, some students, it's actually pretty common for students to give me that this is the line. It's not necessarily wrong, but remember, lines go on forever unless there's some reason that they stop. So go ahead and connect those dots and then extend the line past it. All right, let's do this next one. So our slope is -1/2 and our y-intercept is 5. This is not a right or wrong thing, but I highly recommend that if you have a negative slope, to put the negative with the numerator, because what that means is you're going to go down 1, and then whenever you do your run, you'll always run right. So we're going to go down 1 over 2 for our slope, and then there's our y-intercept. So let's first go ahead and write the equation of our line. So it's y is equal to m. M is our slope, so a -1/2, x plus b, our y-intercept is +5, so we can just say +5. So now let's plot it. So we're going to plot the y-intercept first, or we could say that the line begins here at 5, and then from there, it moves. How does it move? It moves down 1, right 2. We've got two points, so now we can connect those 2 points and extend our line. Next. Here, it's a little bit tricky for students sometimes, but here's what you need to remember. It's really nice when slope is in a fraction form, which is why I almost always prefer fractions over decimals, because you can see that the numerator is the rise and the denominator is the run. If you have a whole number, all you need to do is remember how to write that as a fraction. So this is actually 4/1. So what does that mean? That means we're going to go up 4, right 1 when we do our slope. And then our y-intercept is -6. Let's go ahead and write the equation. So y is equal to mx plus b. Our m represents our slope, so we can say 4x plus b. It's going to be plus a -6, which we could just say -6. And now let's go ahead and plot that. So we're going to plot the y-intercept first here at -6. Then we're going to rise and run from there. What's our rise? It's up 4, 1, 2, 3, 4. What's our run? It's 1. And then we can plot, or we can connect those dots with a line. Next, Our slope is 1, our y-intercept is 0. Remember, we can rewrite whole numbers or integers as fractions by putting a 1 on the denominator. So what that means is we're going to go up 1 and right 1. Okay, what's our equation? It's y is equal to mx plus b. So our m value is 1. We can put x and then plus 0. Now, this isn't wrong, but it's not necessary to put the 1 or the 0, so we can rewrite that as just y is equal to x, and hopefully you recognize that this is the linear parent function. Now, you already are familiar with what the linear parent function looks like, but let's actually do it based on slope-intercept form. So our intercept is 0, or excuse me, our y-intercept is 0, our x1 is also, but for this one, our b value is 0, and then how do we move? We're going to go up 1, right 1. So we're going to go up 1, right 1, and we could continue that if we wanted to, up 1, right 1, and now we can connect our dots with a nice straight line, and look, we have the parent function. All right, next, our slope is 2. Remember, we're going to rewrite that as a fraction, so it's going to be 2 over 1. What does that mean? The way we're going to move is we're going to go up 2, right 1, and then where are we going to begin plotting is at negative 5. Let's go ahead and write our equation. Y is equal to mx plus b, so the m is 2, and then it's going to be plus a negative 5 for the b value, so we can just put minus 5. So there's our equation. Let's go ahead and plot the graph. So we're going to start with the y-intercept first, and then rise and run from there. Our rise is 2, up 2. Our run is right 1. And now we can connect our dots with a line. And next, our slope is negative 3. Again, integers we can rewrite as fractions by doing a 1 on the denominator. Remember, it's not right or wrong, but I highly recommend that you put the negative with the rise. What does that tell us? It means we go down 3. And if the negative is always with the rise, then you will always run to the right. So let's write our equation. Y is equal to m. Our m value is negative 3. X plus b, our b value is 2, so negative 3x plus 2. And now plot the y-intercept first. Remember how we're going to move is we're going to go down 3, right 1, and connect our dots with a line. All right, the next example here is probably the hardest example, or the hardest type of question we're going to do, so make sure you guys are paying attention here. So it's asking us for what's the equation of a line with a slope of 4 that passes through the point 1, 3. Now before, we were able to write the equation of the line if we had the slope and the y-intercept. So all of those previous examples gave us the slope and the y-intercept, but here we don't have those. We have the slope, so that's good. That gets us closer to our equation because we have an m value, but we don't have a b value. So what I want you to do is think about what slope-intercept form is. It's mx plus b, or y is equal to mx plus b. We have an m value, so we can go ahead and we can replace the m with a 4, but look at what we also have. We don't have a b value, but we do have an x value and a y value. So what can we do? I always say plug in what you know and solve for what you don't. So what we can do here is we can replace the x right here with a 1, and we can replace the y right here with a 3, and then the only thing we'll have left as a variable is the b value, so we can solve for our y-intercept. So here we're going to say instead of y, we're going to put a 3 is equal to m. Our m is a 4. Instead of x, it's a 1, and then plus b. Now you're going to use those skills that you learned right at the very beginning of the year to isolate your variable, so we can simplify. 4 times 1 is 4. Now what's keeping b from being isolated is the 4, so we're going to subtract 4. Whatever we do to one side, we do to the other, and we end up with b equaling negative 1. Now we have the b value, and we have the m value. We can write the equation. So y is equal to m is 4x, and then plus b, so it's plus a negative 1, so we can just say minus 1. I want you to notice at the end, you want to make sure your x and your y are variables again. I always have students every year that would give me that this is 3 is equal to 4 times 1 minus 1. That's a true statement, but this is not slope-intercept form. This is slope-intercept form where you have an x and a y. Okay, and it gets a little bit harder for this one, but not too much. Now, notice what we have are only 2 points that are on the line. So we're missing both the m value and the b value. Well, we want to go back to the previous lesson because we can figure out the slope of a line. So let's do that. We're going to use slope formula. So m is equal to y2 minus y1 over x2 minus x1. Let's go ahead and label our points. I'm going to say this is x1, y1, and here's x2, y2. So now we can just plug straight in there. So y2 is 7, minus is in the formula, and then negative 3 over our x2 is 6, minus our x1 is 4, and then we can continue to simplify. Minus and negative is a plus, so it ends up being 7 plus 3 is 10, over 6 minus 4 is 2, so that means our slope is 5. So now we have part of what we need, and we can do now it kind of becomes exactly like this example right here. We have more information than we need now because we've got two different ordered pairs. So choose one. You have two, you can choose one of the two. I don't like negatives, so I'm going to go ahead and use 6, 7 for now, plugging into our just plain x and plain y. So in place of y is equal to mx plus b, I still don't have a b value, but I do have a y value. I'm going to use a 7. I do have an m value because I found it, it's 5. And I also have an x value, which is 6. So let's do that. So in place of y, we're going to put 7 equals, in place of m, we're going to put 5. In place of x, we're going to put 6. And then we can say plus b. And now back to the beginning of the year, we're solving for b. 5 times 6 is 30. We'll subtract 30 from both sides and get a negative 23 is equal to b. Now we have all of the information we need. We have that the slope is 5, the y-intercept is 23, so therefore our equation is, remember, put x and y back in, so our equation is 5x minus 23. Make sure you rewatch that if that was hard for you, because I think that's as complicated as this lesson gets. Okay, the next section is we're going to have to learn to convert linear equations at points, because sometimes you're going to be given a linear equation and it's not going to be in slope-intercept form, but you want to put it in slope-intercept form so that it's easy to graph. So let's do that. Remember, slope-intercept form is y is equal to mx plus b. So I want you to just keep this in mind. You need to get y by itself. So we're kind of going back to the beginning of the year where we're asking ourselves, what's keeping y from being isolated? And we're undoing things to get y by itself. So let's do that. So here, y is we want to end up down here with just y is equal to. Well, what's keeping that from happening? We've got a negative 3 that's being multiplied here and a 2x that's essentially being added right here. So what do we deal with first? Just like before, we're always going to deal with addition and subtraction before multiplication and division. So I'm going to subtract 2x from both sides. Now we're closer to our goal. We've got negative 3y is equal to 12 minus 2x. So what do we do next? We're going to divide, because negative 3 is multiplied by y, we're going to divide it. Whatever we do to one side, we do to the other. So then we end up with, this now cancels or becomes a 1. So we end up with a y is equal to. Now here's the key. You need to look at this as 12 over negative 3 minus 2x over negative 3. You need to divide both parts by negative 3. So 12 divided by negative 3 is negative 4. And then a negative 2x over negative 3 is a positive 2/3 x. Now, I want you to notice the order here. This is actually y is equal to b plus mx. Remember, don't always think of slope as the first number and y-intercept as the second. Think of slope as the coefficient of the x and y-intercept as the constant when y is by itself. So now we can go ahead and graph this. So we're going to plot the y-intercept first, so that's negative 4. And then we're going to rise and run from there. So we're going to rise 2 and run 3. Now we can connect our dots with a line, and we've got our equation graphed. Okay, next one. Here's a super common error. If I ask somebody to identify the slope and the y-intercept here, I get a lot of students that would tell me that the slope is 5 and the y-intercept is negative 40. The other thing I often see students do is tell me that the slope is 5x. It does not include the x, it's only the coefficient. So let's just keep in mind here. In order to identify the slope and the y-intercept, you need y by itself on one side of the equal sign, and here it's not. Well, it's fairly quick to isolate it, so what we need to do is just divide both sides by 20. Now remember, just like before, we want to divide the 5x and the 20, so we need to look at it like 5x over 20, and we need to look at it also as negative 40 over 20. So 5 over 20, remember, both of those numbers have a 5 in common, so 5 divided by 5 is 1, 20 divided by 5 is 4, and then 40 divided by 20, or minus negative 40 divided by 20 is negative 2. Now we've got our slope is 1/4. What's that going to do? We're going to go up 1, right 4, and then our y-intercept is negative 2. So let's go ahead and plot that. We're going to plot the y-intercept first, and then we're going to go up 1 over 4 from there, from the y-intercept. Connect our dots with a line, and we've got our equation graphed. Okay, last one is a weird one, but I think it's really important to see. So we've got y plus 3 equals 6. We can't identify slope and y-intercept until we've isolated our y. So let's go ahead and do that. So think what's keeping y from being isolated is the 3. It's being added, so how do we get rid of it? We're going to subtract it. Whatever we do to one side, we do to the other. Now y is by itself, but we end up with no x value. So 6 minus 3 is 3. This is always going to be a horizontal line. Anytime you see an equation where it's just a y is equal to some constant, it's a horizontal line. Let's talk about y. If you think about y is equal to mx plus b, think about what number for m would make that whole term disappear. Hopefully you're thinking if m is 0, then that whole term disappears. And then what do you have left is only the b value. So here's the deal. The 3 here is the b value, and the m is 0. Remember from last lesson, horizontal lines have a slope of 0. So let's graph this. We're going to plot the y-intercept first, and then the slope is 0, so that means it's horizontal. It's flat. Okay, finally, we're going to do a practical example, and we're going to do some review of previous lessons, just because the concepts of domain and range and independent and dependent variables is just a hard one. So we're going to keep practicing until everybody has it. All right, so here's our scenario. Mason took a Lyft from his apartment to the airport. He was charged a flat fee of $10 for the ride, and then an additional $3 per mile. Write an equation in slope-intercept form to represent the scenario, and then answer the questions below. So some of you will look at this and automatically be able to tell me that the equation is y is equal to mx, the m is the slope, so that's a 3, plus b. The y-intercept is 10, and we'll go ahead and answer this question. It asks for it in function notation, so all you have to do is replace the y with an f of x. Now remember, you can always go back to creating a table and identifying a pattern and figuring out your equation based on that pattern. But you can always also remember that the b value is always the initial value. And the m value is always some sort of rate. And so, again, look for the word per. And so if you can identify the m and the b, it sometimes saves you a lot of time making a table and identifying a pattern. Okay, so let's go on and talk. We'll kind of back up and do A and B. So it's asking for what's the slope and what does it represent? We've already kind of talked about this. The slope is 3. Make sure you do not tell me that it's 3x. It does not include the x. It's just 3. What does it represent? It's the cost per mile for the lift. What is the y-intercept? We already said that that's the 10. And this is the flat fee. Or if you think about it, it's like if Mason just ordered the lift, he may still get charged that $10, even if he doesn't end up driving in it. So the y-intercept is always some sort of initial value. All right, so now let's go ahead and graph the scenario. When we graph it, we're going to have to think about independent and dependent variables. A good way to look at this is look at the equation. Remember, the independent variable corresponds with the x, and the dependent variable corresponds with the y. So think about what's changing it here. It's $3 times what? Hopefully in that you're thinking it's times however many miles Mason has to go to the airport. So we're going to go ahead and label the x-axis as the number of miles. Now, what's the y? 3x plus 10. If you do $3 times however many miles to the airport plus 10 more dollars, what do you get? Well, hopefully you're seeing that that's going to be the total cost for the lift. Okay? So now we can go ahead and graph it. Remember, just like the examples before where there wasn't a practical scenario, we can still go ahead and say plot the y-intercept first and then rise and run from there. So we can plot the y-intercept here, and then we're going to rise. Remember, the slope is 3, but we can look at that as 3 over 1. That tells us to go up 3 and right 1. So from 10, we can go up 3 and right 1. Up 3 and right 1. Now, I want to show you this. This is okay to do, but notice it's not a very good view of the graph, okay? So what I want to also show you here is maybe a way that you can do this differently to be able to show a view of the graph a little bit better. So we're going to go ahead and make our scale 1, but because that graph was all up here, what you can do is let's do a break. You have to put the symbol to show that there's a break happening, and then we can start with 10 and then start counting by ones. Okay, now if we did the equation, it would look a lot nicer. So we can plot the y-intercept first, and then we're going to go up 3 over 1, up 3 over 1, and so on, okay? So now we've got our graph. Now let's talk about it a little bit more. Is it right that I connected the dots, or should those dots have been left disconnected? Well, if you think about it, if the airport is like 9.5 miles away, Mason's going to get charged for that mile. He's going to get charged for partial miles. So because of that, we're going to go ahead and say that this scenario is continuous. Let me go ahead and add my labels back to where it was. This is our cost. Okay, so I'm going to go ahead and connect the dots. And now if you can see, we've got a little better view of the scenario. Now, finally, we're going to do kind of an add-on here. We're going to say, if the airport is 10 miles from Mason's apartment, what is an appropriate domain and range? So remember, our domain deals with the number of miles. Okay, domain goes with X, goes with independent variables. All those things go together. So our domain, the smallest number in our domain would be 0. The largest number in our domain, remember we're talking about the miles, it would be 10. And then we can say X for our variable, and it goes from 0 to 10. If we wanted to do interval notation, we would say 0 and 10 are included with brackets, and that's how our interval notation would look. Now, if we did our range, remember our range is the total cost. So you want to think about what's the smallest amount Mason could possibly pay in the scenario? Well, it's $10. And what's the most money, or what's the total cost at the end? So if he did, in fact, make it all the way to the airport, well, that would mean that he's gone the full 10 miles. So think about if he spent $3 per mile times 10 miles, that's going to be 30, and then 30 plus 10 is 40. So what we can say for our range is it goes from 10 to 40. Remember, our variable is y, and it's showing that we're between 10 and 40. We'll use less than or equal to signs. And if we did interval notation, then we can say 10, 40, and put brackets around both. Now, we also can go ahead, and our graph is still not going to be this big, but if our graph was bigger, we could, instead of putting an arrow there, now we can continue this, and then eventually it's going to have an end point. So that would be our most accurate graph. All right, make sure that you highlight any questions that you have and be ready to ask those next time I see you.